So converting it to our standard form, we are given that the objective function is maximize z is equal to 350x plus 450y, and constraints are x plus y is less than or equal to 35, x plus 2y is less than or equal to 38, 2x plus 2y is less than or equal to 50. So our standard form is maximize function still is the same, so z is equal to 350x plus 450y, and for the constraints we will add s1 as a slack variable to constraint 1. So our first constraint becomes x plus y plus s1 is equal to 35. Second one becomes x plus 2y plus s2 is equal to 38 after we add s2 as the slack variable. The third one, we add s3 as a slack variable, 2x plus 2y plus s3 is equal to 50, and x, y, s1, s2, s3 are greater than or equal to 0. This shows our original initial matrices. So what I have done is I have essentially defined what are the variables in our constraints x, y, s1, s2, s3, and the first matrix is the constraint matrix has x as 1, 1 and 2, y as 1, 2 and 2, and s1 is 1 in constraint 1, so 1, 0, 0, s2 is 1 in constraint 2 and 0 otherwise, and similarly s3 is 1 in constraint 3. And I named them P1, P2, P3, P4, P5, and XB, the right hand side matrix, should look like 35, 38, 50. The Z matrix, if we take all the variables on the left side, becomes Z minus 350x minus 450y. So that means our Z matrix becomes 350 with a negative sign, 450 with a negative sign corresponding to y, 0 for a S1, 0 for an S2, 0 for an S3. And in this case, the B matrix will be based on our basic variables, which are S1, S2, S3, and we have 1, 0, 0, 0, 1, 0, 0, 0, 1 corresponding to 1, 0, 0, 0, 1, 0, and 0, 0, 1. And it's an identity matrix, so inverse of an identity matrix is the matrix itself. Now, I would like you to calculate the new column vectors Pn prime for the non-basic variables and also for xb. Then I would like you to identify the new basic variable if exists by calculating the value of Cn prime for non-basic variables, and then find the exiting row using the xb prime and the new value of Pn prime.